Hello everyone. Today we'll discuss Cohen-Sutherland line clipping algorithm. Right? You all know what is clipping. Clipping is a procedure that identifies the portion of an image is either interior or exterior of a specified region. This specified region is known as clipping window. Right? Clipping is a procedure that identifies whether the portion of an image is either inside or outside of a specified region. This region is clipping window, and this clipping window I can design in any size, any shape and in any orientation. It is not necessary I have to design a clipping window in only rectangular shape. It can be of any size, any shape, and it can have any orientation. Right? And today we'll be discussing about this Cohen-Sutherland line clipping algorithm to find the visible part of a line. That is, if a line passes through the clipping window like this, right, the portion of that line that is inside to my clipping window will be made as visible in my output. The portion of the line that is outside the clipping window will be made invisible in my output. Right? And this algorithm uses region codes to find the visible part of my line. That is, inside the clipping window, the region code will be 4 binary zeros. Right? Now, this algorithm explains how I can find the visible part of a line using this region codes. Right? So, I'll be having 4 bits, bit 1, bit 2, bit 3 and bit 4. Now, I have to find the region codes of these regions. Right? Inside my clipping window, the region code is 4 binary zeros. Right? Now we'll see what is the region code to the left of my clipping window. Right? In the left side, to find the left side region code, I'll make bit 1 as 1. Remaining bits will be 0. So the region code will be 001. To find the right region code, I should make bit 2 as 1, remaining will be 0. So it will be 0010. To find the bottom region code, bit 3 will be 1, remaining will be 0. So it is 0100. To find the top region code, bit 4 will be 1, remaining will be 0. Now to find these region codes, I can take XOR operation of these two values. Right? To find this region code, I have to take XOR operation of these two values. Right? So to find this region code, I have to take XOR operation of 001 and 1000. So what will I get? I'll get 1001. So I should write here 1001. Right? To find this region code, either I can use XOR operation or I can check like this. Right? Here you check bit 2 is 1, here bit 4 is 1. So I can make bit 4 as 1 and bit 2 as 1, remaining will be 0. Right? Either I can take XOR operation of these two, or I can find bit 1 as 1 and bit 3 as 1. So remaining should be 0. Here it should be bit 3 and bit 2. Right? Remaining should be 0. So using these region codes, right, this algorithm, Cohen-Sutherland line clipping algorithm, finds the visible part of my line. Right? Here I have 3 cases. Right? Suppose if my line is like this, you all know to draw a line, I need only 2 endpoints. So first endpoint I'll take as P1, second I'll take as P2. I have drawn a line, and the endpoints of both the endpoints of the line lies inside the clipping region. So the line is interior, and the line should be made as visible in this case, right? Next case is my clipping window. Both the endpoints of my line lies outside the clipping window, right? But this line passes through the edges of my clipping window. So what I have to do, I have to calculate these intersection points to find the visible part of my line. So in this case, I have to calculate the intersecting points. Next, case 3. I have a clipping window. Both the endpoints of my line lies outside the clipping window. In this case, line is exterior to my clipping window and it should be made as invisible. Right? Coming to this algorithm, I'll explain case 1. Right? You know, in case 1, both the endpoints of my line lies inside my clipping window. And you know, inside the clipping window, the region code is 000, right? That is, if P1 and P2 has 0 region codes, right? Line is interior and it should be made as visible. Right now. Next, case 2. Case 2. Right? I'll explain with this. Suppose if my line is like this. Right? First endpoint is in this region. Second endpoint is in this region. Right? You can see both the endpoints, right, has a non-zero region codes, right? Only inside the clipping window I'll have 0 region code, right? Rest everywhere I'll have non-zero region code. So if I have non-zero region code, the endpoints lies outside my clipping window, right? Suppose if both the endpoints have non-zero region code, what I have to do is like I have to take logical AND operation and I have to check the result whether it is a non-zero value or 0 value, right? So here P1 and P2 has non-zero region codes. In this case, what I have to do, I have to take logical AND operation, right? So what is the value here? 0 1 0 1 0 1 0 0, right? 0 1 0 1 0 1 0 0. Take logical AND operation. It is 0 0 1 0. And if the result is again non-zero, it shows line is exterior and it should be made as invisible. This is my case 2, right? Next is case 3. In case 3, again I have 2 subdivision. The first subdivision is I have a clipping window, right? One endpoint lies inside the clipping window, other endpoint lies outside the clipping window. That is, one point will have a 0 region code. You know, only inside the clipping window I'll have 0 region code, right? Other endpoint, right, since it is outside, it will have a non-zero, has non-zero region code. Region code. This is one case, right? Something like this, right? You can check only inside the clipping window I'll have 0 region code. Rest everywhere I'll have non-zero region code. That is, if one point has 0 region code and another point has non-zero, means one endpoint lies inside the clipping window, other endpoint lies outside the clipping window. This is case 3, A case. B case is, right, both the endpoints P1 and P2 has non-zero region codes. Right, you know, if both P1 and P2 has non-zero region codes, I have to take logical AND. Here also I have to take logical AND. Take logical AND operation and check the result. If the result is 0, right, it shows line is interior and it should be made as line is interior, right, and I should calculate intersecting points. If P1 and P2 has a non-zero region code, take logical AND. If the result is a 0 value, right, calculate intersecting point. So in case 3, I have to calculate intersecting points. I have to calculate intersecting points. Case 3 has 2 subdivisions, either for this case, right, one endpoint has 0 region code, another endpoint has non-zero region code. For this also I have to calculate intersecting point. For this B subdivision, both the endpoints are non-zero value, I have to take logical AND, and if the result is 0, right, I have to calculate intersecting points. Right, now we'll discuss how to calculate this intersecting points. Right, coming to the calculation part of this intersecting point, I have to calculate the intersecting point now. Calculate intersecting points. I'll take this case. Suppose if my line is like this, right, this is my first endpoint P1, this is my second endpoint P2, right, you know both the region codes are non-zero, right. If both the regions are non-zero, what should I do? I have to take logical AND. Take logical AND 0 0 0 1 1 0 0 0, right. What about the result? The result is 0. So in this case I have to calculate the intersecting points. So how many intersecting points I will be getting? I will be getting intersecting, here one intersecting point and here another one intersecting point. Now this is my case, right. So coming to the calculation part, right, I'll take this line endpoints. Line endpoints as x1, y1 and x2, y2, right, and this intersecting point I'll take as x comma y. That is, I am supposed to calculate this x comma y, right. So I'll take this case. If you consider this case, right, this is my clipping window, right, and if you take this vertical line, in this vertical line only this y value keeps on changing. Here What about this value? X min, Y min, right? So Y min, Y value, it keeps on changing, and at this point Y value will reach the maximum, right? So here and here the X value remains the same. So at this point, right, anywhere in this line X value remains the same. I have to find out only the Y value, right? So I have to find only the Y value, right? Now to find the Y values of vertical line, Y values of vertical lines, I'll use my slope formula. You know, slope m is equal to y2 minus y1 by x2 minus x1, right? I'll draw this line here, right? This endpoints I have taken as x1, y1, right? And this is x2 comma y2. This intersecting point I have taken as x comma y. And you know, throughout this line x remains the same and y keeps on changing. So here I have to calculate only y, right? To calculate this y value, I'll use this slope formula. M is equal to y2 minus y1 by x2 minus x1, right? And substitute this slope formula for this part, right? x1, y1. Here in the place of x2, y2, I have x minus x comma y. So what will I get as for m? Y minus y1 by x minus x1. From this, can I calculate y? So y will be m into x minus x1, which is equal to y minus y1. From this, y will be y1 plus m into x minus x1, right? Coming to this x value, I told throughout this line x remains the same. Throughout this line x remains the same, right? So x value can be x min, x is equal to x min, right? Or x is equal to x max. So if it is left boundary, x will be x min. If it is right boundary, x will be x max. Suppose if I have a line like this, if it is intersecting with the right boundary, for in the place of this x, I should take the maximum value of x. Here in my example, my line is intersecting with the left boundary, so x will be x min. X is equal to x min for left boundary and x is equal to x max for right boundary, right? Similarly, I have to calculate x values of horizontal lines, right? So here next case is x values of horizontal lines, right? I'll take this case. See, now again my line, it is intersecting with the horizontal line of my clipping window. Right here, how to draw this diagram? I'll draw the diagram like this. Right? This and this. So how to find this m? y2 minus y1. M formula is y2 minus y1 by x2 minus x1, right? So here I'll consider this is x1, y1, and this point, intersecting point, always I'll consider as x comma y, right? So y minus y1 by x minus x1. From this, right, if you take this horizontal line, right, horizontal line, y remains the same, only x keeps on changing. X starting from x min, it keeps on changing and it will reach x max. So x remains the same. What I am supposed to calculate, right? X I have to calculate. Y remains the same. So here I have to calculate x, right? So how to calculate x? M into x minus x1, which is equal to y minus y1. From this, x minus x1, which is equal to y minus y1 by m. Right, from this if I calculate x is equal to x1 plus y minus y1 by m. Now coming to this y value, right, y value, it can be y is equal to y min for bottom boundary of my clipping window, or y is equal to y max for top boundary of my clipping window. That is, see here my line, it is intersecting with the top boundary of my clipping window. This is left boundary, right boundary, bottom boundary and top boundary. My line is intersecting with the top boundary. My line is intersecting with the top boundary, right? So what y value I should consider? I should consider the maximum y value. Y should be y max. In this place, maximum y value I should substitute. Suppose if my line intersects like this, right, it is intersecting with the bottom boundary. So in this y value, what value I should substitute? Minimum value if it is intersecting with the bottom boundary, right? So these are the two formulas to calculate x and y for my intersecting point, right? I'll tell once again, in this point my y value, in this point my y value changes, so I have to calculate y alone. X remains the same throughout, right? Coming to this case, here y remains the same throughout this line, y remains the same throughout this line, y remains the same. So which value keeps on changing? X keeps on changing, x keeps on changing. So if it is intersecting with the bottom boundary, x min I should take, right? If it is intersecting with the top boundary, right, I should take I should take maximum y value, right? Now with this formula, I'll be explaining a sum in next video.